Hello friends, today we are going to discuss about the Porter governor, and here you can see the apparatus for the Porter governor. This is the pointer here for measuring the height of the governor, you can see here, and just above that you can see the fly balls of the equal masses. Here the weight of the balls clearly mentioned, and this is the sleeve, the weight of the sleeve here mentioned clearly. As it is a loaded type governor, so here there is a central load which is attached to the sleeve, moving up and down along the spindle. The central rod is called as spindle, you can see here. And now you can see this is the electric motor which is used to run the whole system or whole apparatus, you can see. Now you can see here the line diagram of the governor. Let me introduce about the governor here. It consists of two balls of equal masses which are attached to the arms. These balls are known as governor balls or fly balls. The balls revolves with a spindle which is driven by the engine and through bevel gears. The balls and sleeve rises when the spindle speed increases and falls when the speed decreases. The sleeve is connected by a bell crank lever to a throttle valve. The supply of the working fluid decreases when the sleeve rises and increases when it falls. When the load on the engine increases, what happens? The engine and the governor speed decreases. So this results in the decrease of centrifugal force on the balls, and hence the balls moves inwards and the sleeve moves downwards. So downward movement of the sleeves operates a throttle valve at the other end of the bell crank lever to increase the supply of working fluid, and thus the speed of the engine increased. And on the other hand, when the load on the engine decreases, the engine and the governor speed increases, which results in the increase of centrifugal force on the balls. This results in upward movement of the sleeve, which reduces the supply of the working fluid, and hence the speed decreased. In this case, the power output reduced. So now let me tell you about the experimentation of the Porter governor. Here we are performing, as you know, on Porter governor to find the stability and sensitivity. So let me tell you about the Porter governor a little bit. What is Porter governor? Porter governor is a modification of the Watts governor with central load attached to the sleeve, as you can see in the apparatus also, and as we have mentioned in the earlier explanation. So the load moves up and down in the central spindle, and this additional downward force increases the speed of revolution, which is required to enable the balls to rise to any predetermined level. Now let's move to the procedure of the experiment. First of all, we have to assemble the governor to be tested, complete the electrical connections, and switch on the main power. And you have to note down here the initial reading of the pointer on the scale firstly. And switch on simultaneously the rotary switch. Now you have to note down the reading of the RPM of the spindle on this tachometer. Now slowly increase the speed of the governor until the sleeve is lifted from its initial position by rotating variac. Again you have to note down the final height of the governor from this pointer scale. Again you have to note down the RPM at this particular stage. with the help of the tachometer. Again, you have to repeat the same process and let the governor be stabilized. Note down the sleeve's height and relative RPM. Increase the speed of the governor in steps to get the different positions of sleeve lift at different RPMs, and decrease the speed of the governor gradually by bringing the variac to 0 position and switch off the motor. Simultaneously, you have to note it down all the readings of the height of the sleeve and speed relevantly, and make a table as you can see in this observation data sheet, and you have to find out the centrifugal force for each and every reading, and finally you can find out the sensitivity of the governor as the formula shown in this data sheet. Thank you very much for watching this video.